No human being has crossed the threshold into deep space in over half a century. Think about that for a second. Since December 1972, when Apollo 17's crew splashed down and closed the final chapter of the Apollo era, humanity has stayed close to home, never venturing beyond low Earth orbit, never returning to the moon, never pushing that boundary again. Entire lifetimes have unfolded in that gap. People were born, built careers, raised families, and grew old without ever seeing another human journey into deep space. And now that changes. As early as April 2026, 4 astronauts will climb into a spacecraft and do something no one has done in 53 years. They will leave Earth behind, not just orbit it, not just look down at it, but truly depart. Their destination isn't a space station or a satellite, it's the moon. Their names are Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. Each one represents a milestone. One will become the first woman to travel beyond low Earth orbit. Another will become the first person of color to make that journey. Another will be the first non-American to go that far from Earth. Together, they are the crew of Artemis II, and what they're about to experience is far more intense, more confined, and more dangerous than most people imagine. Let's walk through it, moment by moment, from the instant they strap in to the moment they slam back into Earth's atmosphere 10 days later. It begins on the ground. Launch day at Kennedy Space Center in Florida. The astronauts have already been in quarantine for days. No contact with the outside world. No last-minute dinners with family. No spontaneous goodbyes. Everything is controlled. Sleep cycles, hydration, calorie intake, fine-tuned to ensure their bodies are in peak condition for launch. They suit up in Orion Crew Survival System suits. These are not the sleek, cinematic suits you see in movies. They're bulky, pressurized, and built for one purpose: survival. If the cabin loses pressure, these suits keep them alive. They're more like personal lifeboats than uniforms. Then comes the elevator ride up the launch tower at Pad 39B, the same historic ground that once launched Apollo astronauts toward the moon. History doesn't just echo here, it feels present. At the top, their spacecraft awaits. Orion, perched atop the most powerful rocket NASA has ever built, the Space Launch System. It stands 322 feet tall. Fully fueled, it weighs about 5.75 million pounds. Beneath the crew are 2 massive solid rocket boosters and 4 RS-25 engines. Engines derived from the Space Shuttle program but upgraded, repurposed, and pushed to new extremes. In total, they will generate nearly 9 million pounds of thrust at liftoff. Inside the capsule, the 4 astronauts strap into their seats. The space is tight, about 330 cubic feet. NASA compares it to 2 minivans. But imagine 4 adults living inside that space for 10 days. Every movement, every object, every breath shared. There's no privacy here, no extra room, just systems, equipment, and each other. The countdown begins. At 0, the engines ignite. First, the RS-25s roar to life. Then, a fraction of a second later, the solid rocket boosters ignite, and everything changes instantly. The force is overwhelming. Astronauts who've experienced launch describe it as if someone is sitting on your chest, pressing down with relentless weight. On Artemis II, that force reaches about 3 times Earth's gravity. Their bodies feel 3 times heavier. Breathing takes effort. Lifting an arm becomes nearly impossible. And then there's the vibration. The solid rocket boosters don't just push, they shake. Deep, violent vibrations ripple through the entire spacecraft, through the seats, through the astronauts' bodies, down to their bones. It's not something you can train for. It's something you endure. This continues for about 2 minutes. Then, Suddenly, the boosters burn out and detach. The shaking stops. The ride smooths. The core stage continues firing, pushing them faster and higher, until about 8 minutes after launch, the engines cut off. And just like that, silence. Weight disappears. Arms float upward. Straps loosen. Small objects drift into the air. They're in space. Now begins orbit. They circle Earth in a highly elliptical path, checking systems, verifying everything. This is not routine. This is critical, because once they leave Earth orbit, there is no turning back, no rescue mission, no safe harbor. Every system must work perfectly. Life support, navigation, communication, thermal regulation, propulsion. Everything is tested. And then something unusual happens. The astronauts take manual control. This isn't autopilot anymore. Wiseman and Glover will actually fly the spacecraft themselves, testing how Orion handles in real conditions. They'll perform precise maneuvers, simulating future missions where astronauts may need to dock with lunar stations or position near the moon's surface. This is human piloting in deep space. Behind them, the European service module provides power, propulsion, and life support. Without it, Orion is just a shell. With it, it becomes a true deep space vehicle. Once all systems are verified, the mission reaches its most critical moment, the translunar injection. This is the burn that sends them to the moon. The upper stage ignites, accelerating the spacecraft to escape Earth's gravitational pull. Faster and faster, until they are no longer orbiting Earth. They are leaving it. When the burn ends, the stage separates, and suddenly they are alone. 4 humans inside a capsule, moving toward the moon at thousands of miles per hour. The next 4 days are unlike anything most people can imagine. Earth begins to shrink behind them. At first, it still fills the windows. Then it becomes smaller. Then smaller still. Eventually, it's just a glowing sphere in the distance. Communication with Earth develops a slight delay. Not enough to break conversation, but enough to feel strange. You speak, and there's a pause before the reply comes back. A subtle reminder. You are leaving. Inside Orion, life becomes routine, but a very strange routine. Food comes in pouches, freeze-dried meals rehydrated with water, no kitchen, no table, just floating packets of shrimp, pasta, tortillas. Crumbs are dangerous. They can clog filters, so everything is eaten carefully. Sleep happens in tethered bags attached to the walls. No beds, no rooms, just 4 people floating side by side in a metal capsule filled with the constant hum of life support systems. Hygiene is minimal. Wet wipes, no showers. Toothpaste is swallowed or wiped away. Exercise is mandatory, 30 minutes a day, to slow muscle and bone loss. The equipment is small, basic, and shared. And through it all, there's the awareness of where they are. Farther from Earth than any human has been in decades. Then, something incredible happens. The moon appears. At first, it's distant. Then it grows larger. Day by day, it fills more of the window. Eventually, they reach the far side. No human has seen this view up close since 1972. The far side of the moon is different. Rougher, more heavily cratered, less familiar. It's a place humanity has barely explored. At their farthest point, they will be over 230,000 miles from Earth. Earth itself becomes a tiny blue dot, small enough to cover with a thumb. Every person who has ever lived, hidden behind a fingertip. That's the scale of what they're experiencing. But this isn't just a moment of awe. It's also dangerous. Beyond Earth's magnetic field, radiation becomes a real threat. Cosmic rays, solar particles, invisible hazards passing through the spacecraft and through their bodies. If a solar storm erupts, they have limited protection. They gather, in shielded areas, near storage, or even near the toilet, whatever offers the most protection, and wait it out. There is no real shelter, just mitigation. After looping around the moon, gravity takes over. The spacecraft swings around the far side and begins its journey home. Another 4 to 5 days. Earth slowly grows larger again. The crew continues their work, monitoring systems, recording data, evaluating how Orion performs with humans on board. Because this mission isn't just symbolic, it's foundational. Everything they learn feeds into future missions that may land humans on the moon again. And then comes the most dangerous part of all: re-entry. The spacecraft slams into Earth's atmosphere at roughly 40,000 kilometers per hour. At that speed, air compresses into superheated plasma, hotter than molten lava, glowing around the capsule. The heat shield takes the brunt of it. It burns away, layer by layer, carrying heat with it. Inside, the astronauts feel the pressure build. G-forces increase. Breathing becomes harder. The windows glow. Communication cuts out. For a few minutes, they are completely alone. No contact, no updates, just heat, force, and motion. Then, finally, the spacecraft slows. Parachutes deploy. The descent stabilizes. And with a final impact, the capsule hits the Pacific Ocean. Recovery teams move in. Divers secure the capsule. The hatch opens. Fresh air rushes in. The astronauts step out, unsteady, disoriented, but alive. They've just traveled farther than any human in over half a century, all inside a spacecraft no bigger than a small vehicle. And that's the reality of Artemis II. It's not glamorous. It's not spacious. It's not safe in the way we usually define safety. It's 4 people, confined in a tiny capsule, eating from pouches, sleeping on walls, and trusting that every system works exactly as designed, because out there is no margin for error. And yet, they go anyway. Because exploration has never been about comfort. It's about pushing boundaries, taking calculated risks, and stepping into the unknown. Artemis II isn't just a mission. It's the moment humanity opens the door to deep space again. And this time, we're not just visiting, we're preparing to stay.